So the first implementation that we are going to discuss is a naive string matching algorithm, and we have already seen a simple implementation of the naive string matching algorithm in the last video. Now in this video we are going to make a programs to implement this naive string matching algorithm, right? So we'll be making the function, assuming the function is make it naive. So name the function is naive, and this function should take two strings as input. So in C language, this strings are implemented as array of characters, as we know. In Java and in .NET, the strings are implemented as classes, but here strings are implemented as array of characters. So we have to take those array of characters as input. We have to take those two strings as input in this given function, and then we can find out what is that string. Okay, so we can just take those. Assuming that we are also going to take the length of those strings as well as what is the string itself. So we are going to character. The first is pattern, or let us say character star text, and the second is pattern. So character star pattern. Okay, and then the length of the string. So integer n, which is the length of the string, and length of the text, and integer m, which is the length of the pattern. Okay, so we have now we have taken the inputs as text as input, pattern as input, the length of text is input, and length of the pattern as input. Now we have to use a loop to find out their length. So as we know, so just for the implementation purposes, let me just explain it again, that we are going to have an entire string like this. And this string can have any characters. It may be A, B, C, A, D, A, C, something, anything, right? So it may be having any number of characters here, like H, right? So this is representing the text, and the length of the text is n, and we may be having a pattern. So assuming that this is representing the pattern, which is having A, B, A, C, and D, right? And this is representing the pattern. Now we need to find whether this pattern is present inside this text as a substring or not. But here in this case, if this pattern is present and wherever this pattern is present, we are going to return the index locations of those places, right? It may happen that the pattern may be repeating multiple number of times. So we may be returning the index locations of those starting index location of those locations where this exact pattern is present inside this text. So if the length of the pattern is n and length of the text is length of the pattern is m, length of text is n, so we have to search in this text, and we have to go through in the naive string matching algorithm. We have to match with every index locations here, and in worst case we are going to match with n minus m plus 1 locations. So we will be having a loop which is going to run n minus m plus 1 times. So we'll be taking integer for integer I is equal to 0 and I less than n minus, or less than, make it less than equal to n minus m. So because if you are going to make n minus m, then obviously because I is starting from 0, that is why it is going to run n minus m plus 1 times. So either we can make I less than n minus m plus 1. Okay, so this is how you can write. So you can make I less than n minus m, or you can less than equal to n minus m, or you can make I less than or less than n minus m plus 1. So both the implementations are fine, and every time you are going to implement the value of I. Correct? Now here we need to implement the next loop, which is the J loop, which is for the pattern, that every time you have to compare the pattern from the text. Okay, that we have already seen the implementation, right? So we are going to take the next loop, which is for integer j is equal to 0, and this j should be less than m. So we have to make j should be less than m, because j should run for the pattern and the length of the pattern is m, and we are going to make j plus plus. And this time if in this place we can say text of I plus j is not equal to pattern of j, that means if they are not equal, then we are going to break Okay, so this is the first condition that we need to write down. Okay, this is the condition, right? So this is what we need to write for this loop, correct? So, and if after this loop, if the value of j is equal to m, that means we found the pattern j is equal to m, then printf pattern found at the index location, which is printed by %d comma /n comma I. So this is a very simple implementation of this one. Okay, let us first check whether it is working correctly or not. We are going to take two characters, two text. So character, assuming we'll be having, let us take 20 index locations, and let us assume the text stored as my name is Himanshu. So how many characters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and base is 20. So there are 20 characters. Okay, make it this much only. So there are 20 characters, and then we have to take the text that we need to find out. So character, how many characters are there? Assuming that we are only trying to find 4 characters. So this is the text, and this is the pattern, character pattern, and here it will be assume HIMA. So we need to find this one. Okay, so we are going to pass it to this function which is nav, and here we'll be passing the text, we'll be passing the pattern, we'll be passing the length of the text which is 20 and length of the pattern which is 4. And now we are going to implement this function. We are going to see whether it is working or not. So we are going to build and run. So there is an error here, so let us find out what is it. Okay, so error is because j is only present inside this loop, so I have to make integer j here. If you make integer j here, then correct. Now let us again try and run. So you can see the pattern found at index location 11, and the data which is present at index location is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So right, so index location 11 h is present, so this entire pattern is matching. What if the pattern is not matching? So we can say else. If the pattern is not matching, then we are not doing anything, correct? So if the pattern is present multiple times, what happens if the pattern is present multiple times? And every time the pattern is present, we are going to print the starting index location of those patterns. Okay, now what we'll be doing is we'll be taking a huge data set. Maybe we'll be having a total 10,000 character set, and in those 10,000, in an array of 10,000, we'll be trying to find out whether a given pattern is present or not. And every time the given pattern is present, we are just going to print the index locations of those patterns. Okay, so for simplicity, first of all, we'll write a function where we are going to declare an array which is having 100 index locations, and then inside that array of having 100 index locations, we'll try to insert some values. Okay, and those values will be randomly generated characters, and we are going to use those values to find out a given pattern in a randomly generated text. Okay, so for that we have to limit the range of of this function, which is the rand function. So let me do one thing. I'll just do a simple quick Google search about finding out what is how to limit the range of a rand function. So how to limit the range of a rand function in C. So this is a very simple code actually. You just have to find what is the maximum range you want, what is the minimum range you want. So it should be somewhere. Yeah, so we have to find, yeah, so this is the code that we'll be using to limit the range of the rand function. So I'm just going to copy it here, and let us make changes into this function. So I'm declaring a character text which is having 200 index locations, and in this character we are going to make a for loop to insert random values. So for integer I is equal to 0, I less than 200, and I plus plus, and we are going to insert values here. So to insert values here, so text of I, we are going to make it to point to this, okay, where the maximum value that we want is 90, because ASCII value of Z is 90 and minimum value is 65, and here also minimum value is 65, because we know the ASCII characters, the ASCII value of capital A is 65, capital B is 66, in the same way capital Z is 90. So we are putting some random values inside this text and assuming that we want to find GATE, if this is present in it or not, gate as a text. Okay, so we'll be looking at this. Now we are going to again build and run. So it is saying that it cannot find the character which is gate, right? So it is working correctly, I hope. So let us do one thing. We are going to print all these text values also. Maybe I can also do a printf function here. Printf. We are going to say, okay, so printf, we are going to find %c comma text of I, that is whatever the values we are inserting, we are trying to print those values. Okay, now we are going to again build and run the program. You can see this is the text that we inserted. This is the entire text that we inserted into this array, and we are trying to find out whether GATE, this pattern is occurring in this text. But you can see this pattern is not occurring in this text. Now let us do one thing. Let us increase the size of this entire pattern, make it 2000. So we'll see in 2000 text, can we have a gate as a text? So you can see again in 2000 locations we don't have this pattern which is gate. Maybe in 20,000 we can find it. So if we have a pattern which is of length 20,000, can we find a 4 combination character which is GATE? So again, so we cannot find it. So this is 20,000 characters here. But anyways, you know how we implemented this function. We can take any combination of characters and see if it is present. So let us assume we want to find out ZEEW. So ZEEW, if this exists as a pattern or not. So again, build and run. So you can see pattern found at index location 4500. So at 4500, if you see this code, this entire text, so at 4500th index location, the pattern which may be present. Okay, so we can take any random text like this and we can find out whether this pattern is present or not. In the same way, if for large data sets, maybe you are having a data set which is having trillions of characters or millions of characters, in that way maybe it will become easier to find a given data set. Okay, so this is a very simple implementation which is the naive algorithm, and by looking at this naive algorithm you can find out what is the time complexity of this function. Okay, so what is the time complexity of this function? You can see this loop is going to run order of m times, and this loop is going to run order of n minus m plus 1 times. Therefore the time complexity for this naive function is order of n minus m plus 1 into m. So this is the time complexity of the naive function. Now to improve this time complexity, we introduced the other function, which is the function for that is the Rabin-Karp algorithm. So Rabin-Karp algorithm introduced some changes in the naive algorithm to improve it. Okay, so in the next video we are going to study about the Rabin-Karp algorithm. So in this video we just implemented the naive function. Okay, so let us move on to the next video now.